Okay, next, let's talk about your Newton's second law of motion itself. Now, previously in your first law of motion, we mentioned that your forces are balanced. So now all we need to do is Newton's second law is that forces are unbalanced. So what does that tell us? Your resultant force, okay, I'm just going to write RF. It is now not zero. So it can be a positive value or a negative value. So do you remember the effects of a force? Okay, we're going to write at the side over here. Effect of force is that you can change the speed. You can change the direction. You can also change the shape and size. Okay, but we are going to be more concerned about changing the speed itself. So in kinematics, we actually learn. So the thing is, if you are a positive value or a negative value, you have two different results. If you are positive, what happens is my object will accelerate. If you are negative, you will decelerate. Okay? So basically, we are changing the speed of object, whether it's accelerating, if it's positive, or negative, we will decelerate. Okay? So because of this, just take note for this one, scratch it off, change it to RF is m times a. Now, because a lot of different schools and even textbooks itself, they just use the word F, but this is very, very, very confusing because if you only write the letter F, are you referring to your resultant force or are you referring to your applied force? Those are two very, very, very different things. So you need to be very, very careful. And as I always mention, whenever we're using any formula, make sure that we use SI units. Okay, so more specifically, instead of just writing RF equals to MA, I encourage everyone to write this. F2 minus F1 equals to M times A. So why do I need to write this very, very long-winded version? Because if you actually notice, by writing all of this in one single formula down here, you're actually making it very, very clear to you yourself and the marker that you know what you're using. And when you put in the numbers, you can just notice, hey, I'm missing this value. Hey, I'm missing this value. All I need to do is solve for my one unknown value. That's all. Okay? So let's take a look at this word example. So you can see over here your 20 kg box. Okay, this is your mass. And you have a force of 200. So this force is your applied force. This is not your resultant force. Take note. So they tell you friction is 40. Okay, so what's the acceleration of the box? So first thing, they very kindly gave us the picture. If not, if they don't give you the picture, the step one is to draw your free body diagram. Okay, and I want you to actually take note of the length of the arrows. Because the values are different, big F is longer because it's 200 compared to small f, which is just 40. So it doesn't need to be to scale, but you need to show that they are different lengths. Okay, so your step number 2, okay, is to, instead of jumping straight to the question, I want you all to write this. So you have big F minus small f equals to m times a. Now, in the previous video, in the Newton's first law, we straight away use 0, right? But the thing is, they already tell you that the box is going to be accelerating. So we don't write it to be 0. Okay? So let's just put in the numbers. Big F is 2, small f is 40, m is 20, SI units, don't need to change, and we have an unknown value a. Can you see, just by simply putting in the value, we already have just our one unknown value and we can straightaway solve. This is 160, this is 20a, right? And your a value will therefore be 160 divided by 20, you end up with 8.0 meters per second squared. Okay, so this is how you solve for your values over here. Now, similarly, if the question already gives us acceleration or we calculated it from some kinematics part, right? We can actually identify and solve what's your resultant force. So first thing, 500 kg, initial speed, we will increase, this is your final speed. So to make things easier, this is m, this is your u, this is v, this is t. Okay, so what's your resultant force? Now take same thing, right, RF. So acceleration formula, A is v minus u over t, right? Just 12 minus 8 over 2. We have 2.0 meters per second square. And next one, we want to solve resultant force. Resultant force is F2 minus F1, but this first part here, part 1, there's no F2 or F1, so we straight away just use M times A. What's your M? 500. What's your A? 2.0. So this is 1000. Because it's a force, it will be newtons over here. Okay? Now, for part 2 of the question itself, they tell you that friction is 400. What is your applied force? So first thing, applied force, friction is small f, applied force is big F. So to solve this question itself, the very first thing we want to do is write your equation out. Because we're moving, we have minus equals to M times A, right? Just write this equation out, very first question. So all we need to do now is, we know that your resultant force is 1000. Okay, so we can actually just see it, we are just using this side to solve. Just now in the previous question, we are actually using the second half. So basically you can see most of the time, if you have the values, you can literally just pick and place which number, which equation do I want to use. That's why I highly encourage everyone to just write it in this format first before you start solving any question. So please, a lot of you like to skip steps. Don't jump straight and put in the numbers. Write this equation out, get your method mark, and then you put in the numbers. Because if your numbers are used wrongly, you will at least get method marks. So we don't know what is big F, but we know that small f is 400. So all we need to do is move your 400 over. So it's 1000 plus 400. You'll get 1400. And because this is a force, it will be newtons. Okay? So very important over here. If they don't give you a diagram, we will sketch it up. Sketch it up. Step 2. And then we solve. That's all. All dynamics question, all the calculations questions, all you need to do is draw your free body diagram and use step number 2 to solve for your unknown values. That's all you need to do. Okay, so let's take a look at a couple of examples that we have here. Okay, now first thing, they tell you have 2 different objects that are in contact, and keyword frictionless surface. Frictionless means no small f. Okay, so P have this mass, this is P, this is Q, and they tell you that you push P with 12. So you can see the 12 over here. Okay, and both of them, they tell you that they accelerate. So when you see accelerate, means I have resultant force. Okay, positive value. All right, so first thing is, draw and label the forces acting on Q. So we are only going to focus on Q itself. So since they didn't give us a lot of space to actually draw, if you see part A doesn't have a space, which means we are supposed to draw on top. Okay, so first things first, with every object, we will draw weight first. Okay, weight. So because they tell us to label the force, make sure you label it in full. And take note, you can actually calculate M times G if you want. So 3.0 times 10 is always a good habit to list down what you have. And then your normal contact force. Okay, your normal force. N. Okay, and N will be the same as W, because up and down, you are not moving up and down. We are only moving left and right. So up and down means my forces are balanced. So these two are the same, is 30 Newton. Okay, and last but not least, because there is another force touching this. Okay, so because of this, our normal force, you need to write normal force by the ground or by the surface. Okay, and then there's gonna be a normal force, which is, let's call this NP. Okay, and this is NP by the box P over here, because you have this contact surface area and they tell you they're in contact. So you have another normal force that is 90 degrees over here. Okay, looks a bit messy, but make sure to write your words clearly and nicely so that the markers know what you need. Okay, so all in all, you should have 3 forces. Okay, there's no leftward force, there's no friction, there's no air resistance, because they tell you there is no friction, frictionless surface. Okay, next, calculate the acceleration of both P and Q. Now, typically when we solve acceleration itself, we'll actually use your resultant force is M times A. Okay, so the first thing we want to do is step number 1. You want to sketch your free body diagram. But now the question is, what free body diagram do we sketch off? Do we sketch P? Do we sketch Q? Now, if we just use Q, you'll notice that we have this unknown normal force. So we cannot use Q to solve. But if you try to draw P by itself, you also notice that there's also going to be a normal force here. So what typically when we want to find acceleration itself, we'll use for both objects. Okay, so the very first thing we do is we'll draw P and Q together as one big box. Okay, so first thing, you have the weight of P and Q. You have the normal force of P and Q. Now, you notice when I'm sketching by myself, for yourself, you don't need to write in the words. You, as long as you understand, everything is okay. Then over here, this is a applied force F that is 12 newtons. Is there any friction? Don't have, because this is a frictionless surface. Right? So that is step number one. Step number two, you want to form your equation. Now, because we are moving to the right and left, right? So we'll take big F minus small f equals to m times a. This is our equation, right? So now what we need to do is put in the numbers. What is big F? Big F is 12. What is small f? There's no friction. This is 0. What is m? Now, we are now using the combined mass. So we're going to use 1.5 and 3.0 times a. Okay, so if you want to find the value of a, this is going to be 12 over 4.5. So press the calculator. You end up with 8 over 3, and which is 2.7 meters per second square, and we'll use 2SF. Okay, for those who are not sure why we use 2SF, because if you notice the two values that we use here, they are all in two significant figures. So your final answer should also be two significant figures. Okay, we don't look at the 3, the 8 and 3, they are just ratios. So if you want to be very, very specific, it's 8.0 over 3.0. Okay. So next, let's talk about the force that P exerts on Q. P on Q, which means our Q, we draw your free body diagram of Q. Okay, so this is your answering technique. You want to find the force on Q. Basically, we draw the free body diagram of Q, because if you remember back all the way 2 videos back, what exactly is a free body diagram? What does it represent? A free body diagram represents all the forces acting on that object. So if you want to find the force on that one object, we need to use the free body diagram of that object. So since we are focusing on Q, we need to draw the free body diagram of Q. So this one is a little bit messy. So I'm going to draw another one down here. Okay, sketch free body diagram of Q. Okay, so we just draw this. This is Q. You have the weight of Q. You have the normal contact force of the surface. And you also have the N of P. Okay, so there's no other forces. Number 2, what do? We write our favorite formula. Big F, small f, M times A. Okay, so what is your big F? Big F is our N of P. Small f is 0. What's your mass? Your mass is 4.5. Now, do we know the acceleration? Yes, we do. We actually solved it in part B. Okay, so most of the time, these kind of questions, they're always linked together. So whatever unknown that you found in part B, most likely you can use it to solve part C. Now, take note, we don't use the 2.7. We will use the 8 over 3. Now, why do we use that? Because if you use the 2.7, that's a round up value. That's an estimated value. So if you keep using the same estimated values, the numbers will get more and more wrong. So because of this, we don't do that. So what is the N of P? You notice that your N of P itself will just be 12. Okay? Let me just quickly check. Okay, I think I made a mistake here. Yes, I made a mistake. Because I was wondering how come the values were so similar to the 12. I made a mistake. This mass is the mass of Q. And what's the mass of Q? Q is 3. Okay? So I made a mistake. So you can see how this is very, very easy to make mistake. Even when I'm writing it myself, I'm also making mistakes. So you need to be very, very careful. For those students who don't present their answers properly, you'll get a lot of careless mistakes, because there's a lot of masses, there's a lot of different forces. You need to write things carefully. So you need to be very, very careful. Otherwise, you end up the same step as me. You actually get it wrong. 8 newtons. Okay, because a lot of us just solve without thinking much, and then we just move on, move on, move on. That's how you get careless mistakes. So you need to be careful. This is 8 newtons, not 12. Doesn't make sense to be 12. Okay, and if you notice, this 12 newtons doesn't appear in my free body diagram of Q. Why? Because it is not touching Q. This applied force is applied to the side of P. So if you draw a free body diagram of P, you'll find that this 12 will be there. Because we are drawing the free body diagram of both objects, it includes the P over here. That's why you have this part. Okay? Take note. Huh? So let's do question 2. Similarly, for question 2 itself, basically, you want to double check. Ouch, sorry. You have a mass of 4,000 for your truck, and you have a mass of the car, which is 1,600. Now, if the truck have a force of this one is big F, huh? Okay, on the truck itself, or on the truck, what's the acceleration of the car? What's the force that the truck pulls on the car? Okay, and they tell you that these two are negligible. F is 0. Okay, so you can see at the start of the question, they really give us a lot of information itself. So for those who are worried, you can feel free to jot down what's the value, 1600 kg. This is 4,000 kg. And they tell you that you have a big F of 25123 newtons. Okay? So first thing, if you want to find acceleration, like I said just now, when you want to find acceleration, you need to use this RF equals to m times a, right? So the first thing is, what is this RF? This RF is the force on both objects. Okay? Because if your car accelerates, first thing, if you draw your free body diagram of the car or you just picture in your head, what is the force that is pushing it forward? Is this force, right? And because this is a rope, this is tension. Now, do we know what is tension? We don't, right? So we cannot use the car. So very first step, step 1, we sketch the free body diagram of both objects. Okay, so we just treat the whole thing as one big box. You have the total weight. You have your normal force, and you also have a F that is 25,000. Do you have any kind of friction? No, because they tell you F is 0. All right, so second step, number 2, we just write your equation now. Big F, small f, m times a. So put in the numbers. You have 25,000 minus 0. What's your m? Now take note, because we're using a free body diagram of both objects, we're going to use the combined mass, which is which is 4,000 plus 1600 times a. So if you want to solve for its a, you take 25,000 divided by 5,600. Okay, so press this in your calculator. 5600. You end up with 125 over 28, right? So is 4.5 meters per second square if you use 2SF. Okay, we'll use the smallest 2SF. You can notice the one on top here, 25,000. 25 is 2SF, 56 is 2SF. So we use 2SF. This is your final answer. So acceleration of the car and the truck are both the same value, which is 4.5. So next, determine the force that the truck pulls on the car. Okay, so what happens when you do this? Very first step, we sketch the free body diagram of what? Of the car itself. So let's draw the car. You should have the weight of the car. You have the normal force of the car. And you have a pulling force. This pulling force is your tension of the car. Okay, so you can just call it tension, but just make it a habit. All right. So number 2, resultant force. Now we no longer use F because if you look at the diagram on the left, we have tension. And do we have any kind of friction? We don't have. M times A. Okay, so put in your numbers. We don't know what is tension. We don't know friction is 0. M. Now take note, let's not make the same mistake. This is the mass of the car. Okay, so scroll up. Your car is 1,600. What's your acceleration? Acceleration is the one on top, which is found earlier on. Take note, we use the fraction. So this value times 1600, you end up with another weird number. So tension itself is 50,000 over 7. And if you round it up, this will be 7100 newtons to SF. Okay, now 7100. Okay, so this is your tension value over here, 7,100 newtons. Okay, now this one is 2SF because if you use the original, this is 25,000. Okay, so if you want to be more specific, this is 25,000 over 5,600. So all of them are 2SF, so your final answer is also 2SF. Okay, so your tension is this value. Next one. Now, basically, you see, like we are doing a lot of different word examples, right? Basically, these are all the different word examples. That is the standard questions that they always ask you. That's why we are doing all of these word examples in one shot in this video itself. Okay. The next, you have masses A and B. This is A, this is B, which is 5 and 15 respectively. And they tell you it's a smooth floor. Basically, F is 0. Okay, and they tell you move from rest to the left, and they tell you you have acceleration, which means you have resultant force. Okay, and they tell you that your horizontal force is constant. So big F is 50. Right? Mark the direction of the frictional force acting on A and calculate its magnitude. So the thing is, when you move like this, B will move to the left, A will also move to the left, right? Because the question tells you both blocks move to the left, which means there must be a leftward force. So if you look at your box A over here, A, you have weight, you have the normal force from B, and what else? What is pulling you forward? It must be your friction, because there's no force. The force is only for B. There's no applied force on A. So what is actually pulling A forward? It must be the friction. So we'll draw it. This is the F of A. Okay, this is the friction of A. It must be towards the left. And how do you find the magnitude? Okay, now basically, when you are stuck with this, remember our first step is sketch. We don't know, right? We sketch a free body diagram. What are we looking for? We are looking at box A. So let's take a look at box A, which is what I've drawn up on top. Okay, I'm going to bring it down so we don't repeat steps. So number 2, we'll use the formula. Resultant force is, now that we don't actually have a forward force, we'll use small f, and there won't be any other force. There's no rightward force over here. So this is 0, goes to m times A. So what is small f? This is what you're trying to find, right? What is small f? M is m of A, this is 5.0, and acceleration they tell you is 2.5. So all you need to do is press your numbers, and you'll solve that this is 12.5 newtons. Okay? Then if your school is being particularly strict, you need to change it to 30 newtons to SF. Okay? But only for very, very strict schools. Most of the time, you can just write this. Okay? Next one. In the space below, draw a labeled free body diagram of B. Okay? You want to label all the forces. F is a mark for you. So for B itself, let's take note. Okay? By default, you have the weight of B. Okay? You have a very large normal force. And if you notice, because A and B, they are touching, there will also be a normal force of A. And is there any friction? There is no friction. This is a smooth floor, right? But don't forget, because you're touching A, when you rub against A itself, there's actually going to be a friction of A. Okay, now take note, this is in your opposite direction. Why is that so? Because your applied force itself, this FA, right, is because when I move my box B to the left, the friction that is rubbing against A will always be opposite to that leftward motion. So because of that you actually have a rightward FA over here. Okay, so this one, if you take note, you have a lot of different names, so you need to be careful. This one will be of the, okay, so this one will be F of the floor, for those who want to be more specific. Okay, now, so what's the magnitude of the force acting on block B by the floor? So this is actually the end of the floor. Okay, so take note, because they want you to label all the forces carefully, you should use words to explain. Frictional force by A. This is the weight of B. This is the normal force. This is the other class. This is the normal force by A. Okay, by A. And this is the normal force by ground. Okay. So you don't need to use symbols, you can just use words. Better to use words when they ask you to mark and label. Okay, then for the one below here, you want to find the end of the floor. Okay, so this one shouldn't be ground, this one should be floor. Okay, so what's this? So first thing, when you want to find any values, we'll use this one, because step 1 to sketch is already here. This is step 2, right? This is, now if you take a look at your, this normal force, this is the upward force, right? So we need to take a look at your vertical forces. You have up and you have down. So first thing, let's take your down, right? Your weight of B plus the end of A minus away the end by the floor. First thing, is my box moving up and down? If you notice, you're only moving to your left, which means up and down you are not moving. Not moving vertically. What does that tell you? Resultant force for vertical is 0. So this is going to be 0. Okay. So what does that mean? End of my floor is going to be the weight of box B plus end of A. Now, what is this normal force that we are looking here? What is this normal force? If you think about it, this normal force is actually the weight of A, because you press on B itself. So this is actually the weight of A. Okay. So now all we need to do is put in the numbers. Now, what is B? B is 15 kg. So what we need to do for both of them, hang on, okay, is that this is W equals to mg. Okay, so for those who don't remember, W is m times g. Okay, so what we want to do is 15 times 10, and this is 5 times 10. Okay, so if you go up 5, 10, 15, 15, you end up with 15 times 10, 150, 5 times 10, 50. So this is 200 newtons. Okay, let me just press the calculator to double check. This is 200. Okay, so this is 200. Give me a second. Okay, so then next one, let's talk about your question number 4. Now, question number 4 is one of the harder ones, but this came out for one of the school papers. I think this is for Senix. So this is mass on a frictionless surface. Same thing, whenever you see all of this. So always read the question and pick out all the keywords that you have so that it make your life easier. So next, the trolley is connected to M by another frictionless pulley. Okay, and when block M is released, it will accelerate. Accelerate means I have resultant force, not 0. Okay, and they tell you that this is actually your G. G is 10 meters per second square. So don't be tricked by this acceleration due to gravity. And they tell you air resistance is also negligible. So that just reinforces that F must be 0. Right? Or if you want to be more specific, this will be R. Now, determine the tension in the string as the trolley accelerates from A to B. So tension in the string itself, we have two different tensions. We have this tension, we also have this tension. Okay? Now, determine the tension in the string as your trolley accelerates from this to this. They tell you trolley. So what you want to do is, step 1, you want to sketch your free body diagram of the trolley. Okay, so this is trolley. Free body diagram of trolley. So first thing, you have your weight, you have your normal contact force, and you also have a tension that's pulling you forward. Is there any kind of friction? Don't have, because they tell you frictionless bench surface. So number 2, resultant force is going to be tension minus small f is m times A. Okay, so tension, we don't know what's the value. Small f is 0. What's your m? M is 0.80 kg. And what's A? A is 2.5. Okay, because this acceleration of your block and your trolley are going to be the same. The tension will just be 2. Okay, 2.0 newtons to SF, for those who are wondering. Oh, okay. Next one, determine the mass of block M. Now, mass of block M. So let's draw a free body diagram of block M. Okay, so first thing, you have your block M, you have weight of block M, and you have a tension. Okay, now I want you to take note of this. Because you're falling down, your weight minus tension is M times A. Okay, now this tension that you have down here is the same tension as this. Okay, I'll explain more in the next video, but you just need to know that because they are connected to the same string, the tensions are exactly the same. So first thing, you want to find what is block M. Okay, so what is M? What is W? W is mass times G, right? Minus your tension, which is 2, which is your M, times A. What's your A? Now, take note, the acceleration of both objects will always be the same if they are connected in the same string. Okay, so this is also going to be 2.5. All right. Now, what is mg? What's g? G, they actually tell us that this value, mg, is 10. Okay, so for those who have trouble, take note now. This is w equals m. Let me just use a different color. This is m times g, for those who are wondering. Okay, so basically this just becomes math. 10m minus 2 equals to 2.5 m. So you shift them over, 7.5 m is 2. Let me just write, m is therefore 2 over 7.5. So 2 divided by 7.5 will give us a very weird number, 4 out of 15. And therefore, you will get 0.27. And take note, we are now using mass. So this is kg to SF. Okay. Next one. When the trolley reaches point B over here, the mass M reaches the floor. So the thing is, mass M reaches the floor. Okay. So if mass M reaches the floor, what does that mean? It means no more tension. Cause it's no longer. Okay, wait. This one is your string. Your string is no longer stretched. Because it's no longer stretched, we don't have tension anymore. So the thing is, what's the trolley? So let's draw your step 1. We will sketch your game because we need to explain, right? So let's do this correction. Let's do the steps at the side. So first thing, you draw your free body diagram of your trolley. Okay, this is your trolley. There's no more tension, so you only have weight and normal. So horizontally, resultant force horizontal is going to be 0. Because there's no more rightward force, there's no more leftward force. You do not have no more resultant force. What does that tell us? Our forces are balanced. So if your forces are balanced, what is the keywords that you have? You must move at constant speed. Answer is number 4. Okay. Statement 4. Okay, don't write 4, write IV, follow the question. Is correct. Explain why. So first thing, this is statement explain, right? So your explain is 2 marks. So at the when mass M reaches the floor, the string is no longer tight and stretched. This means that there is no more tension and thus no resultant force acting on the trolley. So by Newton's first law, now some schools don't need you to mention this, but just to make it by Newton's first law, the trolley will move at constant speed. Okay, so you can see all the relationships over here. First thing, because it's no longer tight and stretched, there's no more tension. And since there's no more tension, if you look at your formula, T minus F, right? Both of them are 0, so there's no more resultant force. And because there's no more resultant force itself, there will be, you will just move at constant speed. Okay? Alright, so that is the end for this video.